Today I'm going to show you how to draw out a pedigree, and I'm going to show you this because pedigrees allow us to track traits through families. And so my problem that I've given you on your study sheet is albinism is a recessive disorder. This is where you lack a pigmentation to express your usually fair skin, blue-eyed. And the family that we're dealing with starts like this. So Earl and Marge have 3 daughters, Peggy, Joy, and Kara. And Peggy and Joy do not have albinism, but Kara does. This is a recessive disorder, so don't forget you have to inherit 2 alleles in order to express this trait. Now, Peggy and Kara do not marry, but Joy marries Steve, and they have 3 sons, Mike, Mark, and Mick. And Mick is also shows albinism. So let's draw this out and then also share the genotypes for this particular family. So let's start with Earl and Marge. That's our first sort of generation. Earl gets a box because genetic males get boxes, genetic females get a circle just by convention. And again, they have 3 daughters, Peggy, Joy, and Kara down here. Peggy and Kara do not marry, but Joy marries Steve to show somebody married in. They don't like sort of follow the bloodline. Instead, they're hanging off the side. So here's Steve married into the family. And then Joy and Steve have 3 sons, Mike, Mark, and Mick at the bottom here. Now I'm going to put in the names so that you can track this. So this is Earl and Marge, and then this is Peggy, Joy, Steve is her partner, and then Kara. And then down here we have the 3 sons, Mark, Mike, and Mick. Now, the first thing that you have, once you have your generation set up, here's generation 1 at the top in a line, and then generation 2 with the daughters in a line, and generation 3 with the grandchildren in a line. Once you have that set up, then you're going to work out the genotypes for this particular family. For a recessive disorder, when you have to inherit 2 alleles in order to express a trait like albinism, then I always sort of fill in the people who have the trait first. So in this problem, it's stated that Kara has it, and so she will get filled in. She has albinism, so lacks that pigmentation, and so doesn't Mick, the last son. Now, in order to write in our genotypes, we need abbreviations for our alleles. So I'm going to allow a capital N to be sort of your normal pigment, and then a lowercase n. I'm mostly choosing these so that you can tell the difference of them. So this is if you have that sort of lack of pigmentation. So let's go back and then sort of fill this out. Since we know our recessives, we know the people who have homozygous recessive for albinism, we can add in Kara is going to be a lowercase n, and so isn't Mick, right? The offspring of Joy and Steve that also doesn't show that particular pigment. Once you have your recessives listed, then you can go back and add at least 1 capital N to every other member. Every other member in our sort of pedigree does not show the trait. That means at least 1 of their alleles is normal pigmentation so that they can express those pigments. The second letter, however, for each of these, you have to puzzle solve out. And so for Earl and Marge, because they have a daughter, Kara, that has albinism, right? She's lacking the pigmentation. She's a recessive. She's inherited 2 recessives. It means she must have inherited 1 recessive from her dad and 1 from her mom in order to express that particular state. And so we know that these 2 are heterozygous. Coming down here, Joy and Steve are the same. They have Mick down here, so they would also have a lowercase n. But let's look at Peggy. If Peggy has a capital N, she doesn't express this particular disorder. Let's pretend that we know that sort of normal pigment gene came to her from her dad. She still has a 50-50 shot of getting either a capital N or a lowercase n. And because we don't have enough information on her, we have to give her a question mark for that second letter. And the same happens for Mark and Mike down below here. So this ends our pedigree. We've now shown a family, we've tracked this particular trait and how it's passing through this family with 3 generations, and we've included the genotypes.